Hello one and all, and welcome to today's session of the Azure Back to School series. My name is Mark Patton, and today we're going to look at the topic of DevSecOps and how we integrate security with Azure DevOps. So what is DevSecOps? You'll likely be aware of the term DevOps, where a project is segmented into small chunks within an agile framework. DevSecOps is integrating security at each step of that life cycle. So whether you're coding, building, testing, releasing, and so on, there'll be elements of security introduced at each of these stages. Traditionally, you may recognize a series of security activity toward the end of a project. Now, unfortunately, should there be a fundamental flaw in the solution architecture, there could be potential for significant changes. Rather than leaving this step toward the end of the project, prior to your end delivery, with DevSecOps, we simply seek to perform elements of those tests throughout the life cycle of the project. Now, there's no one size which fits all. Size, architecture, complexity, compliance, and other requirements, particularly if there are specific non-functional requirements targeting security. These may dictate the degree of adoption of specific security techniques throughout the life cycle. And whilst we seek to automate as much of this as possible, there's still room for manual security assessment, but should occur in the manner of the life cycle as you would with other areas such as performance testing, accessibility testing, other techniques and disciplines. So the approach here is to avoid leaving your security analysis and assessment to the end of the delivery. In this video, I'd like to cover just a few of numerous security techniques which can be introduced to the DevSecOps process. But in the context, I want to concentrate on Azure DevOps. So let's take a look at what we'll cover in this session. In Azure DevOps, no doubt you'll have a number of security measures already in place. And this may range from securing access to your repository to defining rules for each user, and even securing which operations a user can perform on your pipeline. What I'd like to do in this video is to cover just 3 areas or techniques which you can use to integrate security to your DevOps lifecycle. Firstly, what I want to look at is code leaks. Some may refer to this as secret scanning. Even if you're using a private repository, and certainly if your repo is public, it's vital that your code base is sanitized of any data which may lead to a compromise of your environment. Just bear in mind on who could be watching your repository for changes. For example, consider an Azure subscription ID. Would you really want that to be exposed? What about a connection string to some Azure resource? Even if you have removed a sensitive piece of data from your code base, is it still in the history of your repository? In the instance of, say, a blob storage key being leaked in your code, you could recycle that key. You could update your connection strings accordingly. However, what if you leak something more sensitive which can't be changed? For example, the subscription ID, and if in a series of leaks over time, which are contained in the history perhaps, there's certainly potential for some serious compromises of your environment. Now, whilst you can cleanse the code of the offending data, you may even proceed to squash your commits. Unfortunately, though, with Azure DevOps, the commit history can't be deleted within the organizational repository, even if you have reinitialized your code. Certainly, you don't want to have to create a new repo and then move your code across. So clearly, prevention is better than cure. To help prevent against such an event occurring, the first part of the demonstration in this video will look at how we can integrate the scanning for leaks. That's the secrets, the keys, and the passwords. And the ideal scenario is to scan locally, and particularly if you're using the Git repository, you may wish to employ a pre-commit hook. But what I want to show is, in this demonstration, how Git leaks, tool we're going to use, how it can be integrated as part of our DevOps process. Secondly, I want to demonstrate checks for identifying vulnerabilities within the code. By using tools such as OWASP dependency check We can attempt to detect publicly disclosed vulnerabilities that are contained within a project's dependencies. It's used to determine if common platform enumeration identifier for a given dependency, and should one be found, it will produce a report linking to the associated vulnerability and exposure entries. Unlike tools such as Snyk, which has its own vulnerability database, OWASP Dependency Check uses the National Vulnerability Database. And if you'd like to know more about integrating Snyk with your DevOps pipelines, you can check my article on the topic over at my blog site at markpatton.cloud. The third and final item I'd like to consider is integrating OWASP's app into your DevOps process. OWASP app is used to assess and test a system to discover security risks and vulnerabilities of a system and its data. Areas it can cover are vulnerability assessment, where a system is scanned, analysed for security issues, penetration testing, the system undergoes analysis and attack from simulated malicious attackers, runtime testing, where the system undergoes analysis and security testing from an end user, and code review. This is where the system undergoes a detailed review and analysis looking specifically for security vulnerabilities. This app can be used to automate a scan by crawling through a web application. It can be by targeting a specific URL. You also can define your own scan to target specific areas of your web application. Now, it goes without saying that if you're going to employ a tool such as this, please make sure you have permission to test the web application. This is a simulation that acts as if it's a real attack. Actual damage can be done, both to the functionality and the data of a site. So in this demonstration that I'm using a targeted URL scan of a test web application that I've created for the purpose of this video. And so those are the three areas that I hope to cover. So with that in mind, let's jump into the first section. First of all, we have to install locally git leaks. You see I'm using the brew install command. I've already got it installed, so I'm just going to cancel out of that. If I display the present working directory, you'll see that there's a hidden git leaks toml file, and it's this file that defines to the git leaks process all those expressions that we define as a password, a key, or a secret. We don't want those to be in our code. You think about the vulnerability if somebody can see those details, particularly if it's a public repository. So here within this file, we've got a series of rules, and we define what constitutes a secret through regular expressions, and we have the opportunity to whitelist or to allow those secrets that may be legitimate or maybe false positives, let's say. I've also added in a definition for a subscription ID and that of an Azure key, and that's the one that we're going to run through a demonstration right now. And so if I run git leaks, the git leaks command, I define the configuration that makes reference to my toml file. I then want to scan the local working directory, so I'm just going to then add in the commit for the latest commit. And as you can see, when we run that, we now have a nice, clean, secret-free code base. And so what I'm going to do now, by way of testing git leaks, is to include a key embedded in a connection string to a storage account. And this is simulating the web app accessing a file store. And I'm going to rename that to file connection. So you can see here I've saved, I'm adding, and I'm committing my changes. And then as soon as that's done, I'm going to push that to the repository. But before I do, as I run the git leaks command again, we've identified there's one leak, as we would expect. And when we increase the verbosity, we can get some information about what that leak contains, albeit it's a little bit hard to read. So we can then prettify that to make it a more readable JSON format. And there we have that line of code that has been added. We can identify what element within that line of code that is the offender that matches our rule. And for the purpose of history, we can see the commit and various tags and also the rule within our toml file that this applies to. Now when we run this in our build pipeline, we don't want to expose the actual secret itself, and so we use the redact parameter when we run the command. So right now I'm going to push this up to the remote repository. And so for the purpose of this demonstration, I have set the git leaks build to immediately initiate as soon as any commit has been made. And you'll see that we've got redacted from our output of the build that specific line of code that is now been identified as a leak. And why is this incredibly important that you test your code for leaks on every commit? It's also extremely important that you run the very same test when you're creating a pull request. You don't want to expose your secrets into that of another branch. And so one way we can do that is on our pull request here. As you can see, I'm assigning a policy that when a pull request is created, a check must be made on return successful with that of the git leaks build pipeline. And as you can see here, I have created a pull request. I've assigned a policy to the branch I'm wanting to merge with. And as a request has been created, then there will be an initiation of our git leaks build. And that's going to examine our code for anything that we define as a credential that should not be there. And as you can see, as we delve into that particular run, that we've identified that that leak exists. And so at this point, anyone who is seeking to approve or to complete a pull request will not be permitted to do so. And so a process of remediation is required. And so because we are running these security checks right at the very early part of our DevOps process, it means that we can identify potential sources of leaks or vulnerabilities. And as you can see here, we're removing those. And because that leak is now, or that key has been added to our history, that will now be in our Git history. The key has been recycled by way of the connection string so that it can no longer be used if someone was seeking to exploit the system. But for further scans, we want to then whitelist. And as you can see here, that key that previously was in the code, I'm putting into the whitelist. And now that we're remediating those changes, I'm going to save, add, commit, and push them to my remote feature branch, which will then update the pull request, run a fresh instance of the git leaks in the build pipeline. And then we should be able to see that we now have a healthy status check in which we can approve and complete. And at this point, our code has now been merged with our target branch. And as you can see, as a result of that PR completion, we have a build that has been automatically commenced through our continuous integration triggers. And so for the next section of our topic today, we're going to look at scanning our code for vulnerabilities. Now for this, I'm using the OWASP dependency check. And as you can see here, I have it installed to my DevOps organization from the marketplace. Now I have created a demonstration MVC application based on .NET Core. And as part of the dependency check, I'm going to restore those dependent packages, which are NuGet in this case. I'm going to then run the OWASP dependency check and then publish the results. And the results will appear then in the test plan section of Azure DevOps. Now by way of a policy, in other words when this is going to run, for the sake of demonstration I'm going to add this to the sprint branch. So anytime a developer wants to make a pull request to the sprint branch from their feature branch, the vulnerability check will be run. And so in order to create a change or an updated commit to my feature branch, I've removed the connection string that we added in the previous section. Now we've got an updated commit. That's now going to be pushed to the remote repository. And when we create a pull request, which will merge the code from my feature branch into that of the sprint, It's at that point that the policy will then run the code vulnerability scan, and if it passes, then we can approve and complete the pull request. And as you can see here, the check is now about to commence. Now that it has completed, you can see if we go into the results which have been published, we can identify that there are a number of areas that need to be addressed. Now, for sake of demonstration, let's just go into one of these in particular. And what we can do is we can create a bug. And this is where in the concept of DevOps, or integrating security to DevOps, we are able to create a new work item, have a developer work on it to address the potential or the security concern, and then that gets brought back into our code base through a new commit, and we go through the whole process of checking the code for leaks, checking the code for vulnerability, and we can continue on in that life cycle. Now, to examine in a little bit more detail the results of that previous scan, you can see here that we've been able to produce an HTML report, and this is one in particular. Now, should you find yourself needing to suppress what you may deem as a false positive, and therefore we can take that little snippet of XML and we can add that to a suppression XML file, which we can reference as a suppression path within our dependency task. And as you would expect when running such a task as this, you can set the threshold for which you want to decide whether the task fails or passes. And we look at the code vulnerability scan that has been run as part of our pull request, we can then see that there has been a failure of that role to meet the threshold at which we have set. Now when we look, and this is one of the really nice features of the run section within test plans, we've been able to publish those results, and we can see the list of scans that have been run for our project, and specifically those areas that have failed. And just like we did in the previous section, the developer will remediate those changes. Those will be committed to the feature branch, brought into the pull request. The check then is run, and obviously what we want to see is a code vulnerability scan that matches the threshold which we've set. Now we can approve, we can complete, and our code then gets merged with our branch. What we want to see then, having completed the pull request, that our CI triggers then initiate the build of our application. That in turn then will also lead to a release. And finally we come to the last topic of today's video, and that is the ability to run penetration tests within Azure DevOps. Now you see here within this pipeline I have defined a task, which is really using a WASP's app, and I've set the threshold of this task to 0. That simply means that if there are any vulnerabilities identified, the build itself will fail. And so we're using handlebars to generate a template from which we can report, and then we use the handlebars template and report from the scan to generate an XML report in NUnit style with which we can display. And then lastly, we publish those. And so now, to demonstrate the scan in action, I'm going to create a pull request. Quite similar to what we did earlier in the previous sections, I've created a policy on the branch with which we're going to merge, and that will do a check that will essentially just run the penetration test against the site that we've stipulated within our build. Now I'm doing a targeted test on a specific URL, but particularly if you've got some expertise around defining a WASP configuration, you can add that as well. And you can see here our threshold has failed. We've got failures above the threshold of 0. Now we can go into the dashboard and we can quite clearly see that we've got a number of fields, and I'm just going to pick one here at random. Our affinity, you'll be familiar with that in terms of wrap services. Let's just, for the sake of this demonstration, let's create a bug. And what this really allows us to do is to identify vulnerabilities in the code, We can create work items that then can be passed back to a particular team, development or security or whoever it might be appropriate for. And we effectively start the whole process again. We remediate, we commit, we PR, we complete, and we resolve the issues as we go. As you can see here, now that we have refreshed the pull request, I can requeue that, and fast forwarding, you can quite clearly see that that now has successfully run. And so now our pull request is in a position with which we can approve and complete. And finally, we come to the end of the chain. Successful completion of a pull request has led to a successful build. That build has obviously triggered a release, and now we're through into our release pipeline. We've examined the code by way of checking for leaks, vulnerabilities. We've been able to check the site even before we release the new version of the code. As we go through to acceptance, the code gets successfully deployed. It will then go through post-deployment. And it's even at that point where we can examine even some further security techniques, which unfortunately we can't cover in today's video. And so there we have it. That concludes looking at just 3 areas of how we can integrate security as part of our lifecycle within Azure DevOps. If you'd like to know more, or you want to discuss Azure DevOps or maybe areas of Azure in general, please feel free to contact me on LinkedIn, Twitter, or you can visit my website at markpatton.cloud. Thanks for watching. Enjoy the rest of your day.